Let's have a look at financial maths, and in this case, a pension fund. John has decided to put money into a pension fund for the next 25 years. So what's happening here is that he doesn't have money, so he go from zero money to create a pension fund. So at the end of the 25 years, he's going to have money. Now, as well, one thing that we have to identify in our question, are we talking about a lot of payments? Doesn't matter whether we are creating a pension fund or repaying a loan, or are we talking about one-off payment? So if it is a lot of payments, we'll just write that many payments, let's call that if we have many payments, well, then we have two options. We can use the formula for sum in geometric sequence, or we can use amortization formula. If we are talking one payment, therefore we go for the formula that has to do with compound interest. So that's first thing to identify when you are dealing with financial question. Do you have many payments or do you have one payment? And in this case, because he is creating a fund, there's going to be many payments because he's going to put money every month. So many payments. So now the only question is, are we using the sum formula or are we using amortization formula? What's the difference? How do we know? When it comes to amortization formula, we have to be paying at the end of the period. If he is paying at the beginning of the period, doesn't matter what, is it monthly, weekly, yearly, doesn't matter, that amortization formula is not going to work for us. Now, however, that formula for the sum in geometric sequence will work for the end of the period and the beginning of the period as well. So that's the difference. That formula will always work as long as it is many payments. But like I'm saying, if we are talking about the end of the month, we have actually two options. And there will be another video after that where I am actually showing you an example that both of those formulas can work. But let's focus on this part. So he's putting 285 in his fund at the start of every month for 300 months, because 25 years multiply by 12 months will give me 300 at an interest rate of 0.355 per month. Now, the problem with that formula, let's actually get, that's the question. Let's write the formula for the sum in geometric sequence. Where do we have that formula? In our table. So the problem with this formula is, well, what do we fill in for N, R, and A? Okay, that is the issue. Now, depending how you've been taught about that, I kind of like to follow logic. What do I mean by that? When he goes to the bank the very first time, so this is the 25 years time, so this is the beginning. This is when he take a decision that he's going to do it. He go to bank or pension fund, doesn't matter. Today he decides, today he gives them money. That money is going to be working for him for all of 300 months, isn't it? So that's the way I'm looking at it. I'm looking at the fact that the first term that we're going to consider, that will be there for 300 months. And then the last one, let's think about the last one. So the last payment, because at the beginning of the month, so the last payment he's going to do will be there for 1 month. So that's the way I like to look at that formula. So what we have to do here is that we have to write the total amount of money in his pension fund at the end of the 25 years as a sum of series. Because why? He pays money, and then he pays money, and he pays money, and so on, all the way to the end. And then at the end, he's going to have that fund. So therefore, we are adding all those values. That's why it is a sum. So we have to include the first two and the last two. So like we said, the very first one will be there. So my term 1 will be there for the whole period of 300 months. And the last one, so every month for 300 months, so the last term will be actually 300, will be there for 1 month. And then obviously then the term 2 follow the same logic, so it will be 1 month less for 299 months, while the term before the last two, so 299, will be there for 2 months following the same logic, isn't it? Okay, so now how do we write it? Okay, so let me just explain a little bit here. So here I prepare a table to show you how it works for our SN formula. So that's what I'm saying. Very often it's difficult to identify, well, what am I putting in the place of A, R, and N? Now, in the table, I did include the term 2, so you understand how the terms are created. Because very often in your question, again, you have to do the first 2 and the last 2. Whether we are going from whether it is investment, and usually it is investment, like in this case pension fund, when we are going from not having a fund, zero money, to having money at the end, we therefore identify, like I said to you, 2 types of situation, whether we are paying at the beginning or at the end. So like what we said, today we take decision, today we put the money in the bank account, and that money is there for 300 months, is working. So the money we're going to pay in will incur interest for 300 months, isn't it? Because they are using that money for 300 months. We give them that money and they keep it and they use it. So therefore, it's going to be there for that period of time. If we are paying at the end of the month, well, today we take a decision. So today 300 months start, but we are paying them at the end of the month. So my first payment will not work for that first month because it will be at the end of that month that I'm going to pay them. When we are looking, and usually that situation is the debt, or we could have a fund, we could have a money, and then at the end of the period, we going to use that, or we're going to pay off the loan. Then here we are looking at a different part of our compound interest formula. So here we are saying that F is the money that we are getting from that fund, and it is divided by an interest rate. So again, if I have the money and today I decide to, because I have a fund, I retired, and today at the beginning of every month, I'm going to take a specific amount from that fund, well, then that first money I'm taking is not going to incur any interest. That's the reason why power of 0. And then in order to make it simple, for every time, as you can see it, R is always expressed in the same way, 1 divided by 1 plus interest rate, and N always means all periods in the particular example. Okay, but back to our question. Let's apply that now. So that means that his first term will be A, meaning the money that he is paying and how much he's paying, 285. And that is going to be multiplied by 1 plus interest rate. So that will be 1.0035, because interest rate in this case was 0.35%. So if we change that to a decimal, it becomes 0.035. And that is taken to the power of 300 because that's how long it works. And then the second term. Again, that money is going to incur interest for 1 month less. So therefore, the power here, as you can see, it all periods minus 1, 291 plus, and then all in between. And then we are getting to our last. So we said the not the last, the one before the last, that's going to be there what, for 2 months, isn't it? So that's the reason why we are saying to the power of 2 is going to incur interest, and the last one will be there for 1 more month only. So therefore it will be power of 1. So that is the sum of all those payments he's going to make. Okay, then let's have a look at the next part. So therefore, we have to find the total amount of money in his pension fund after the 25 years. So now all I have to do here is to fill in those values into my SN formula here. So let's write that formula again. So my SN, and that will be what? 300, because that's how many terms I am adding. So my first term, again, what was my first term? That's 285 multiplied by 1.0035 to the power 300. That's that part of the formula. So let's write it. 285 multiplied by 1.0035 to 300. So that's my A. That is multiply bracket 1 minus, and then R, like I'm saying, always it will work if we express it that way, 1 over 0035. And that R is taking to the power, isn't it? And my power N is all period, meaning 300. And then divided 1 minus an R again without power. So if we put all of that in our calculator, press equal, we're going to get 151,367.63. So I hope that those clear things for you when it comes to financial maths. Like I'm saying, that part, that's what it is crucial, and identifying, is it the beginning of the period or is it the end of the period? Yeah. And well, first of all, let's recap again. First, is it many payments or one-off payment? If it is one-off payment, we go for compound interest formula. If it is many payments, we have option of sum formula or amortization. However, amortization only works at the end. SN formula is going to work for both beginning and the end. And then there will be another video where I'm actually showing you how both of those formulas work for the end of the period.